Hello world, I'm Athena Angeles. In this video, I will be introducing you to Athena, my solution to the general problem statement on building a searchable knowledge base with generative AI. Athena is a highly customizable retrieval augmented generation system that enables users to manage, search, and interact with their data. In the next few minutes, I will show you how I built this AI-enabled tool with Azure. The first key function of Athena is data management. Under the Documents tab, users can upload their documents to an Azure Blob Storage container. This enables the customer to centralize all enterprise data, which was previously spread across multiple storage solutions. Here, they can also search for specific files by name and delete any documents that are no longer needed to free up space in their storage containers. The second key function of this web application is its full text search capability. In order for new documents to be searchable within 1 to 2 days, I have configured an Azure AI search indexer to run daily. Manual runs can also be triggered in the app by clicking the Run Indexer button in the Search tab. The crawler will extract textual data from the PDFs available in the cloud and populate a corresponding search index. Additional fields have been mapped to the standard schema to include the results of built-in and custom skills that I have integrated to enrich the documents being processed. These include the text split skill that partitions the documents into chunks and an embedding skill accessed via a web API. The latter will come in handy in part 2 of the solution. Athena will retrieve the top 3 sections of the document that match the query inputted by the user. It will generate a short summary of each of those segments, which is what appears in the bodies of the cards herein. The titles of the cards link to the original documents being cited. Additionally, this page shows the most relevant direct snippet from the highest-ranking document as the answer. The workflow outlined in the architecture diagram is powered by Semantic Ranker. The third and final key function of this app is the implementation of a RAG pattern, which makes it possible for users to interact with their data by inputting natural language queries in the chat box. The chunk text in the index is vectorized by a deployed Azure function that calls OpenAI's Embeddings API endpoint. The query capabilities of Azure AI Search is used to retrieve content from the vector space to be appended to the query as additional context. The augmented prompt is then passed to the GPT 3.5 Turbo model. The LLM's response is returned to the user as the bot's answer. Athena facilitates a more flexible approach to searching knowledge bases by offering 2 alternatives that can be applied to different business requirements. Having evaluated the performances of both POCs, the full text search appears to be more precise, whereas the vector search or RAG-based implementation seems to have higher recall in terms of returning contextually relevant output. Athena is scalable in that the provisioned resources can be dynamically adjusted based on demand. Building out new features is another way to increase adoption rates. Such improvements include using multimodal models such as the GPT-4 Vision model to handle formats other than PDFs like JPEG or PNG files. We can also set up authentication with Microsoft Entra to further personalize the responses based on the user's chat history, as well as to enable document-level access control. Athena can address common needs and challenges across various industries. It increases the availability of information within an organization, enhances productivity, and supports self-service workflows. Having been built in Azure, it can be readily reconfigured to incorporate the latest developments in AI and cloud computing. This is a step into a new era of intelligent search, where your next great insight is just a query away.